That already brings us to the first agenda item, which for some odd reason is me. I used to do a bit of an opening, trying to talk a little bit also at the past summits about some current trends that are going on. I'll do this as well. I wanted to talk today, maybe spend 15 minutes or so talking about visual programming for data science, doing complex things the right way. The reason for this is that in recent times, in the recent 12 months or so, there's a lot of talking about democratizing data science, no code, low code type of things. And I often run into the problem that the conception that people have about these terms is wrong. Let's just say it. Because this has nothing to do with doing data science the easy way, right? Reading your book, Data Science for Dummies, or attending one of these $40 courses, how to become a data scientist in one weekend, or checking the little booklet that came with your muesli package, and then 3 days later, you're a successful data scientist. Data science, in the end, is really complicated. So democratizing data science has a lot more to do, and also no code, low code has a lot more to do with finding an environment that allows data scientists to really focus on what they want to do. To illustrate that a little bit, we all know the classic data science life cycle, right? All of this data blending, transformation, modeling, visualization, deployment, management, and I'm deliberately totally ignoring at this for this part of the presentation, at least, this idea of having a business understanding. Of course, you need to understand what kind of a problem you want to solve as well, which is an additional challenge for a data scientist, that they need to put that as part of the process as well. But just looking at that sort of more technical journey, if you look at the types of techniques that people need to be able to handle, they need to know how to do a join, they need to know what an outer join is and the left inner join, they need to know what pivot or normalization, how to do dimensionality reduction, for instance, using PCA, and tons of other things, just on the blending transformation side of the data science lifecycle. Then, of course, we go towards modeling. There's lots of stuff around clustering, regression, deep learning, billions, maybe not, but hundreds of methods out there that you can apply to your data. Not understanding them and just blindly applying them tends to not be a very good idea. And then, of course, in the visualization category, another huge plethora of methods out there to visualize data. And also there, very easy to choose a visualization that actually sends the wrong message. Then when moving things into production, it becomes more important to do model monitoring, know how to update a model, how to validate that the model is still doing what it was supposed to do, and so on. And then at the very end, being able to actually deliver what the data science team built as an interactive application, as a service, having that application keep learning from user interaction is another big thing. So the techniques alone needed for data science activities is pretty broad, right? The other problem is, of course, there's tons of different technologies that are more or less well suited for some of these techniques, right? On the database side, you shouldn't do data blending in Java, right? A very bad idea. You probably want to do that in SQL. You need to be able to deal with all of these data lakes with your internal in-house data sources. On the modeling visualization side, right, there's R, there's Python, but there's also Java. There are fantastic C libraries. And for the visualization, no way around JavaScript, right? Deployment, management, same story here. You probably need to know what Kubernetes is doing, need to write stuff in Go, understand Docker, Grafana, and so on. And for the deployment side, there are all of these JavaScript and browser environments that you need to understand, right? If you think about it from a data science perspective, this is something that the data science team really shouldn't need to worry about too much, right? Good example for us is deep learning. The first framework that we embedded in KNIME was deep learning for Java. In order to use that one, you needed to understand Java, right? Nowadays, the libraries are usually accessible via Python. So if you wanted to switch from that to a more modern version, you also needed to switch the programming language needed to access that. So just as an example for us, visual programming in our mind has something where you actually focus on what you want to do. You're interested in modeling how the data flows through all sorts of things, where it comes from, what you do with it, and how it goes out. You're much less interested in modeling a control flow. You're interested in modeling a data flow. And the data flow inherently is a flow, right? Why not model that visually? Point is, it looks nice here, but what you're hiding and what we want to be hiding from the data science team is all of the technologies that are running underneath the hood, right? And I'm just showing some of the logos here, but you get the idea, right? Different cloud providers, different execution environments, different ways of visualizing data, running models, optimizing models, and also deploying it through some other applications, right? So data science for real, if you really want to do data science, I think the important part here really is, and that often gets kind of blurred a little bit when people talk about no code and low code and easy stuff. Data science is complex stuff. That's why we call it a science, right? It requires a very broad spectrum of skills, and very often you don't even have all of these skills in one person, but it's really a team effort, right? The data engineer really knows where all of the data is sitting versus the AI, ML engineers, the person responsible for optimizing models, right? It does require, and that's an important point here, it requires the understanding and access of the inner wheels of the algorithms. You want to be able to adjust how many layers and which kind of layers are in your deep neural network, but you really don't need to understand the algorithm itself, right? You want to fiddle with the parameters controlling what the algorithm does, but you don't want to fiddle with the algorithm. You don't necessarily need to fiddle with the algorithm itself. And part of that confusion, in my mind, also comes from the fact that a lot of data scientists originally came out of the algorithm development and moved into the role as a data scientist. But we now see increasingly more people being trained as a domain specialist and data scientist without all of this computer science algorithm development background, right? And the other point is no single language or tool has all of the answers, right? So this is very much also about tool blending. Just a few examples just to show, this is just a very, very simple example of doing data wrangling where we're accessing something on Amazon and Microsoft, a few Excel sheets, we do some joining and merging and other stuff. And just that one is we're already dealing with 3 different technologies underneath the hood without necessarily needing to know all of the nitty-gritty details about those, right? And the upper right corner just shows us a very simple illustration. If you have the right environment, then it's very, very simple to take your entire workflow that's doing something really cool that you built, that you visually programmed, and switch it from, in this case, from an Amazon to a Microsoft cloud solution, right? And this type of stuff, different ways of accessing those resources, right? They're all hidden by the framework, but you still have full control over what you want to do. Another example is deep learning, right? I mentioned that already before. You want to be able to assemble the network structure any way you want that. That's sort of what the upper part of this workflow does. But you don't necessarily need to care about what really the implementation underneath is using, right? And then some training. That's one of the reasons why there's an entire book around that, Codeless Deep Learning with KNIME. So it doesn't make it easier. You still need to understand what all of these different layers do and how they need to be assembled. If you don't use a pre-configured network, which you get from somewhere else, you can also do that in this environment. The book, and we'll have a breakout session on Codeless Deep Learning where the 2 authors, Rosaria and Katrin, will also be present. If you go to this webpage, you get and we'll send this out afterwards with the follow-up emails, you get a discount on the book until March 30th. And just one other example, just because that's one of the last workflows I actually ever built, that's literally programming, visual programming, right? We're doing something, there's a control loop, we're looping around. This is recursive feature elimination, which is an algorithm, but it's actually very, very simple to model in a visual workflow. These types of things you can do as well. And there's tons more, right? Just to add feature selection, feature engineering, anonymization, tons of topics here where different libraries, different tools, different ways of doing this need to be embedded into the same environment, so you can use that within the visual programming framework model selection. And then you also start approaching all of these more business organizational aspects, compliant, best practices, required standards, bias detection, removal, data privacy, GDPR. How do we control this, right? If everybody just uses their own favorite programming language and it all gets somehow built together, in a visual programming environment, you have much more control over this one, right? And then governance, integration, traceability, documenting what's going on, visual programs, visual workflows by themselves are great to explain what you're actually doing. So this data science storytelling is a lot easier to do when you show a KNIME workflow versus showing some code. So data science for real, just to follow up, if done right, there's a lot of these visual programming frameworks out there that are they're just sitting on top of one particular technology. That's not what you need. You need something that actually provides the appropriate level of abstraction to allow focus on what you want to do, which is modeling a data process. That's what your data science team is specialist in doing, right? It allows access to all these relevant nuts and bolts, and I think that's really very, very important message here. We don't want to make it easier to use these data science techniques. We want to make it easier to use them at their fullest, right, and deal with all of the nuts and bolts. It removes all of these tool interfaces. You don't need to worry about, okay, this piece that I'm currently using is actually written in C and needs to be interfaced into something else. the framework, the visual programming framework, will take care of that one. And then all of the other things, abstraction, encapsulation, I mentioned that before, these components that we can now, these verified components that you can share, you take a workflow, you bundle it together and turn it into a new node that you can use in other workflows, or your colleagues can use in other workflows. Provides transparency, enables governance. So to me, in a sense, there's kind of two audiences here, right? There's the data scientists, right? What does the visual programming environment provide to the data scientists or the teams of data scientists? There's a consistent UI, and it's one very flexible framework. So underneath the hood, there will be different technologies, but if you don't want to, you don't need to worry about it. You have access to all of the relevant parameters. So I can tweak the learning rates in my neural network and can figure out and decide what kind of a splitting criteria I want to use in my random forest, right? It's all accessible to me, all in the same uniform, consistent way, right? Also very important, this framework needs to handle all dependencies and versions, right? Especially now that we're relying on so many different underneath execution environments and programming languages that are integrated. We need to make sure that if one library gets updated here, it doesn't suddenly break my entire workflow, right? So handling dependencies and versions becomes even more important there, and you don't want your data scientist team dealing with that one. It should just work, right? And then, of course, if they really want to, you always have people that have some expertise. They want to try out something else. They really want to mess with an algorithm, and why not, right? So you should provide the access to the underlying technology when it's desired. But inventing, writing, optimizing new algorithms is usually not the part of the job of the data scientist. And then there's the other side. What does my organization get, right? What's in it for them, so to speak? In it for them is, of course, that I, as a data scientist, I'm actually spending time on what I know how to do, what I'm being paid for to do. But there's also makes it a lot easier to enable collaboration, so my team actually can work very easily together. No technology breaks, none of this fighting over what's the preferred technology. Reusability, gigantic aspect, being able to have blueprints. Look at our KNIME hub, right? We have 4,000 blueprints for very simple problems, to how to solve very simple problems to much more complicated problems. Governments, all of these software integration dependency nightmares, I mentioned that already. Compliance, best practices, permission handling, making sure that only this kind of user group has access to the raw data and the others only see an extract. These types of things become increasingly important with data privacy issues. And then again, documentation, meta information, having a visual workflow explaining precisely what's going on, what you did with your data, what sources of data, which columns were actually used to make this particular decision is also super critical. And again, this documentation is one aspect of a visual workflow, but it also allows you to explain very easily, graphically, what you're actually doing, right? So the team can present to management. This is the data science process that we built. And on that, I wanted to end with a note by Donald Knuth from 1974, who said, computer programming, and note this, he's not talking about coding. Computer programming is an art because it applies accumulated knowledge to the world, so your team of data scientists, because it requires skill and ingenuity. Data science is complex stuff, and especially because it produces objects of beauty. And even though my workflows are butt ugly, a lot of workflows that other people at KNIME are building and also our community building are actually quite beautiful.